Hi guys, welcome back to my channel. So today we'll be learning about ratio and percentages in AOPS Algebra Chapter 6. So now we'll be starting with basic ratios problems, which is lesson 6.1. The first knowledge to know, or vocabulary as you may call, is called ratio. A ratio is a way to show comparison between quantities of relative size. Emphasis on relative size. Why would I put emphasis on relative size? Because one thing for sure is that ratios is basically a horizontal way of writing fractions. And when this happens, they have to simplify. To be simplified, which means they have to lose their actual and exact volume. It may be of the same thing of proportion, but it's not going to be the exact number that you want. So how do you write ratio? A ratio would commonly look like this, used to normally compare more than two figures, such as dogs and cats to hamsters, because this is the most simplest way to write two or more fractions. But when you're trying to solve them, most people would try to use something like this, because most more people are familiar with fractions longer than they have been with ratios. So now we'll be moving on to our first example problem, 6.1.1. The ratio of boys in a school play to the total number of students in the play is 7 divided by 10. What is the ratio of girls in the play to boys in the play? So in here we have one step to solve it. We have to get out a general rule of how many girls of the ratio are in the play and boys, how many boys are in the play. So we first digest the first sentence. The ratio of boys in the school play to the total number of students in the play is 7 to 10. What that essentially means is boys to boys plus girls equal 7 divided by 10. Well, that is just on relative terms. If you want to have the total population, PS is needed for you to keep continuing solving, we have to set up a variable for the total number of students in the play. We'll set this up as X. So now we have boys plus girls equals X. So boys divided by X equals 7 divided by 10. Using cross multiplication, you can get something that looks like this. 10 boys equals 7x. Boys equals 7x divided by 10. No worries, you don't really need to solve for x. Sometimes we use variables just for the sake of it to represent a number we don't know, but necessarily don't need to solve. Now we're going to keep going for girls. Girls over boys plus girls. Well, how do we solve for something like this? Well, we know boys, and since the only other factor is girls, it is basically just 1 minus what the boys have, which is 3 over 10. 3 over 10. Now we represent boys plus girls equals x, so girls divided by x equals 3 divided by 10. Using cross multiplication again, we have 10 girls equals 3x. Girls equals 3x divided by 10. Now the last step. We shall be combining. So we got two answers of boys equals 7x divided by 10 and girls, which is 3x divided by 10. Now we'll be writing it together. So what is the ratio of girls to boys? We put down girls to boys. Plugging in the numbers we have with the variable is first girls, 3x divided by 10, to boys, 7x divided by 10. First steps first, look for any similar numbers that you can simplify. And here the case is 10 and x. So 10 and x are gone. Then we have 3 over 7, which is our total answer. So boys to girls, girls to boys equals 3 to 7. And that will be your answer. Moving on to our next lesson. 6.2, more challenging ratio problems. The concept here is to think of them as two-step ratio problems with more logic thinking. The mistakes that I normally use that I would recommend to watch out for is not paying attention. Well, here I am not saying that you're not paying enough attention to reading or writing, but I'm paying attention to setting variables, or such as actual keywords, or setting too much variables or too less variables could be common factors that could cause you a lot of trouble. So the idea here is to use the ratios and fractions interchangeably. Like you could change ratios to fractions, fractions to ratios very comfortably, and that is what I would recommend to do. Now we move on to our example problem, 6.2.1. The ratio of boy to girl in small town is 3 to 2. The population of big town is 3 times of small town. The ratio is 2 to 3 of boys to girls. If small town and big town combine, what is the ratio of boys to girls? First thing you might notice, combine. That is quite an odd word to use with ratios, as they commonly refer to multiplying and dividing, but adding is not unheard of. So combine means adding. Something to keep in mind until the end of the problem. Now we start deciphering. First sentence. The ratio of boy to girl in small town is 3 to 2. Let's put that down. Small town. Boys to girl is 3 to 2. Next sentence. The population of big town is 3 times of small town. Let's put that down too. Population of big town is 3 times of small town, equals 3 times of small town. Three small town. Okay, that's something. So that basically means if we have one big town, that is equivalent to the size of 3 small towns, which means we could set up big town as x and small town as 3x, which is also something to keep in mind until the end of the problem. Next step, we shall be solving the next line. Ratio is 2 to 3 of boys to girls for big town. Okay, let's put that down. Big town. Boy to girl, we have 2 to 3. Now, we shall be plugging in what we have done before over here into here, so we have an exact answer. So small town is 3x, so times 3x. That is wrong, and you may be wondering why. I got my ratio, I'm just putting in my number. Or you might be thinking, you didn't use the butterfly formation or the crossover, so it's wrong. Well, that's neither reason of why it's wrong. It is wrong because you haven't used the proper stepping. Here, let's go back. You see here, I use the steps of total to boys and girls to total. You see the difference? Right now, I'm not using any of total. They're just boy to girl and girl to boy. So that is something we need to change. Let's put down small town. Boy to total. Using the ways I did before, that should be 3 to 5. Using crossover like before, you should have 3x. So 9x divided by 5 is boy to total in small town. Girl to total in small town is 2 to 5 plus the actual population times the actual population of 3x, we have 6x divided by 5. Same thing with big town happens. Big town is boy to total, which is 2, 5, actual population, x, equals 2x, 5. Same thing with girl happens. Girl, total, equals 3, 5, times x. We have 3x divided by 5. Now, we get everything sufficient enough to do the last sentence. If small town and big town combine, what is the ratio of boy to girl? Let's break that down a little bit more. The first sentence asks, if small town and big town combine. Okay, let's combine them then. We have big town and small town. Boys in big town and small town plus together is 9x divided by 5 plus 2x divided by 5 equals 9x plus 2x both divided by 5 equals 11x divided by 5 equals total of boys. Same thing happens with girls. 6x divided by 5 plus 3x divided by 5 equals 3x plus 6x divided by 5 equals 9x divided by 5 equals total girls. Last step. What is the ratio of boys and girls? Well, boys and girls, we shall put down the ratio. Boys, which we have as total boys, total girls. Boys is 11x divided by 5. Girls is 9x divided by 5. Cancel out everything you know. You have 11 divided by 9, total boys to girls. And that will be your answer. Moving on to the next lesson. Conversion factors. So what is a conversion factor, you may ask? A conversion factor is anything of a scale, like a scale factor. Like when you read a geography map, it'll say in the corner, 2 inches equals 100 miles. This is essentially what happens here, but with a much wider range. You could make up like geeps and goops, or you could be feet to inches, it could be centimeters to miles. It could be anything that has a factor. So why would you use a conversion factor? So basically the main idea is that units cancel. So it's like a less messy equation for you to see and look at and do. So now we'll be moving on to our problem. On planet Gap, 2 geese are worth 3 gips. 2 gips are worth 3 gloops. 3 gloops are worth 2 gups. How many gups is 7 geese worth? Step 1 will be solving in the most common way to solve a bunch of numbers put together. So how do we say that in a more clear way? So it's like I'm trying to solve it in one equation. I'm putting all these conversion into one big equation. I'm solving the big equation in one step. But there's also another way I call it the crossover way, which you break it into each conversion by each conversion and do each in different steps by bringing each answer to the next equation you're going to do. Either one works, but first we're going to try the big equation. So setting up the big equation, the first step is to identify all the conversions. The conversion 1, 2 gees are worth 3 gips. Conversion 2, 2 gips are worth 5 gloops. Conversion 3, 3 gloops are worth 2 gups. And the question, how many gups is 7 gees worth? Okay, let's put that down. 7 gees equal gups. Now we're going to write down all the conversion factors. 7 gees. First conversion, 3 gips divided by 2 geeps. Well, you might be wondering, why is geeps on the bottom? Why is gees and geeps on the bottom? Well, one is that your goal is to cancel everything except for gups. So what I'm doing and putting on the bottom is to cancel out all the gees. Same thing with the next few steps. Times 5 goops and 2 geeps times 3 gups divided by 3 goops. Look, handy dandy comes in hand. We shall now start to cancel. Geeps, 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 goops, goops. Now you have something better, all the numbers. 7 times 3 times 5 times 2 divided by 2 times 2 times 3. Those numbers, if you may be wondering, is here, 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 here. Now you start to simplify. Canceling out 2 and 2, 3 and 3. We have 35 divided by 2 equal 17.5 gups. Gups is all the way brung down from here. Gups. Bring down here, 7 gees equals 17.5 gups. That is way 1 to solve this. Now we try way 2. Way 2, let's start. First steps. How many gups are 7 gees? Okay, 7 gees. The first conversion is 2 gees are worth 3 gips. Okay, I don't know how many gees are in, how many gips are in 7 gees, but we will set up a variable called x. X gips equals 2 gees over 3 gips. So 7 divided by x equals 3 divided by 2. 2 divided by 3. You might be wondering, hey, didn't I just take all that time to write down gees and gips? Well, I only wrote them down to make sure I don't mess up, and the whole entire line is one single conversion factor, not gees to gips to gups. It's just 2. So now we do cross multiply. Gets us 2x equals 21, x equals 10.5. Now taking that in hand, we shall do the next conversion. Our next conversion is 10.5 gips is worth y gloops, which gives us the conversion factor 2 gips are worth 5 gloops. Okay, let's solve. So 10.5 divided by y equals 2 divided by 5. So 2y equals 10.5 times 5. 10.5 times 5 equals 52.5. So y equals 52.5 divided by 2, which is 26.25. Now bring that along to our last and final conversion. Groups to GUPS. Groups is we have 26.25 groups, and it would be worth z GUPS, which gets us the conversion of 3 groups are worth 2 GUPS. Getting rid of all the words, we have 26.25 divided by x equals 3 divided by 2. 3x equals 26. 26.25 times 2 equals 52.5, which gives us the answer x equals 52.5 divided by 3 equals 17.5. Look, Viola, the same exact answer as you got before. So choose what way suits you. Now we'll be moving on to the next problem. The next problem is percents. What is a percent, you may ask? Percents literally means per hundred. It is written in this weird apostrophe thingy-majig. And how to solve percents. Percents have a few common knowledge equations that you should know or learn. One is this one. Second one is this one. So what's the difference between the two? The first one is x is the result of a times b percent. And then the second one is a, which is the total before change, equals b percent times x, or bx divided by 100. So now we'll be moving on to some calculation problems. First one. Number that is 24% of 140. Okay, 140 times 24% equals 140 times 24% divided by 100 equals 140 times 6 divided by 25, which equals 140, 140, 33.6. B. What percent of 84 is 210? You might be saying, easy, it's a fraction. All you have to do is solve it. Right, that is all you have to do. But what incorporates it into it is where it gets interesting. They say 84 is 210, and you would counter with, well, they don't go over 100. Well, percents can go over 100, like 120, 140, 200. So this is actually a special case. So what we will have down is 210 divided by 84 equals our percent. First, we simplify. Both could be simplified by 2, which gets us 105 divided by 42, which equals 105 divided by 42. .5. But that's not all you have to do. Then you have to change it into a decimal. which is what it's already in, but then a percent. So a percent will be moving the decimal 2 points forward, basically like dividing it by 100 is how you change it back from a percent. To change it to a percent, you'll move it back twice, which gets us 250%. Next question. What results from 42 increase by 220%? Well, let's try that. 1, they said increase, and 2, they already put down the percent for you. So you do exactly what you did in A. 42 multiplied 120%. Moving the decimal point 2 points forward, we have 42 times 1.2, which equals 42 plus 42 times 0.2 equals 42 plus 88.4 equals 50.4, which is your answer to C. Next lesson, 6.5, percent problems. So the main concept here is to incorporate what you have learned before from all the way from percents, conversions, to ratio. So you want to put all of that into one little tiny chapter of percent problems. But you might be able to say, well, they say percent problems, focusing mainly on percent. So why do I have to know all of that just to do percent problems? Well, one, obviously, because they can be all interchangeably. You could change fractions to ratios to decimals to percent. So what that could really help here is that if you know how to change all of them comfortably, that could actually be more helpful than if you know logic really well. So here, something else that can really help is pictures. Sometimes they don't necessarily require pictures depending on your understanding in logics and reading, but if you need them, pictures are always helpful, and some problems even demand pictures for the answers. So now we'll be moving on to the question, 6.5.1. While eating out, Bob and Bob Jr. each tipped the server $2. Bob tipped 10% of his bill, and Bob Jr. tipped 20% of his bill. What is the difference between their bills? Well, we shall start. First, analyze the problem. What does the problem ask for? The problem asks for the difference in their bills. When you say of difference, what do you think of first? Subtraction. Okay, let's put that down. Subtracting. Then we start labeling the variables. What's the variables? We know Bob and Bob Jr.'s bills is something that we need to know. Okay, we'll call Bob X, Bob Jr. Y. Next, we draw a graph or just a really simple chart to show us what we're up against. So this is Bob's stack of money. Bob's stack of money, or X's stack of money, has only 10%. That equals $2. His total, we'll pretend, is X, which is his bill amount. Okay, Bob Jr. This is Bob Jr.'s, and he paid 20%, which also equals $2. So Y is his bill amount. So first, we have to find out each and individual bill amount. Let's find the highlighted yellow one, X, or Bob's bill. Bob was a cheapskate and only paid 10%, so that's what we're going to try to solve for. So X is his total, which means X times 10% equals 2. X equals 2 divided by 10%, which equals 2 divided by 0.1 equals $20. Now, let's solve the more grateful Bob Jr.'s who paid $2 out of a 20%. So same thing happens here. Y times 20% equals 2. Y equals 2 divided by 20% equals 2 divided by 0.2 equals $10 meal. Now we find both the answers. We shall be solving for the difference in their bills. The difference in their bills means the bigger to the smallest, or you can do the smallest to biggest. But make sure to use absolute value, which is the distance from 0. Okay, so distance in bills would be Bob minus Bob Jr. Bob minus Bob Jr. Let's put that down and plug in. This one was Bob's bill. This one was Bob's Jr.'s bill. So 20 minus 10 equals $10 difference. And that would be your beautiful, majestic answer. And that's it. Now we should go on to the next problem. Challenge problem. This is our problem to finish off the whole entire chapter. Challenge problem. In a recent election for mayor, there was 3 candidates in total: Mary, Carl, Kristoff. The ratio of Kristoff to Carl is the same as Mary to Kristoff. There was 100 Mary voters and Carl voters with 200. How many people voted in total? Okay, let's identify what we need to find. First things, how many people voted in total? Total will be Mary plus Kristoff, Carl plus Kristoff, which would be, we will set them Mary as M, Carl as K, Kristoff as F. So how many people voted in total will be F plus K plus M. Since we already know Mary, which was 100 voters, and we also know Carl, which was 200, all we needed to find is Kristoff. Well, first, we can try to make a chart, a pie chart of sorts, though we don't really need any of percentages. So this will be our chart. We have 800 Mary voters. We have 200 Carl, and we're trying to find how many F or Kristoff. We will put this into a simple cross multiply equation and slash ratio, like this. So we know something particular here. The ratio of Kristoff to Carl is the same as Mary to Kristoff. That could be put into the straight account. That is what we, and what mostly me, known as the main equation, the main thing you need to know. You could probably solve without knowing that it's a recent election for mayor, but you cannot solve without knowing that the ratio of Kristoff to Carl is the same as Mary to Kristoff. Why, you may ask? Let me put it down into mathematical terms. Okay. F, Kristoff to Carl, K equals Mary, M to Kristoff to Carl is the same to Mary to Kristoff. Okay, you may say, this isn't looking really particular. Now let's plug in the numbers. F, we don't know. We know K as Carl, which is 200. We know Mary as M as 800. Now we simplify. We only have one variable, which makes this extremely solvable. F squared equals 800 times 200, which F squared equals 1600. So F equals square root 1600 equals 400. Now, we're not done. We found all three variables, but we yet have to add them. Remember this? This is what we wrote as the answer. So that's what we're going to try to do. So f plus k plus n equals 400 plus 200 plus 800 equals 800 plus 800 equals 800 times 2 equals 1600. And that will not be your actual answer. Have you noticed what I did wrong? So, the first biggie mistake that I'm pretty sure is amateur is this. That is 600 instead of 800. So that's what we will try to be fixed. So we have instead 600 plus 800, 600 times 2, which 600 plus 800 equals 1400. That will be actually your real answer this time. So that is how many you voted in total. Hope you enjoyed me explaining Chapter 6, Ratios and Percents with you, and have a good day. Bye-bye.